Hello everyone, welcome. In this tutorial, I'm going to show you how to create a simple water sprinkler system using 3ds Max and Tyflow. And trust me, it's way easier than you might think. I've chosen Tyflow for this setup because it's lightweight, efficient, and doesn't put much pressure on your system, especially compared to something like Phoenix FD, which is incredibly powerful, but often too heavy for a simple effect like this. That is the reason why I chose Tyflow. If you're looking for a fast, clean, and controllable way to simulate water spray without all the complexity and simulation times, this method is perfect for you. So let's get started. Here I have a very simple 3ds Max scene with a very simple Tyflow setup. So the most important thing in this kind of simulation is the main structure of the nozzles and the sprinkler itself. If you look at this kind of structure, you will see some different in any sprinklers. They have some differences. For example, this is a curvy nozzle, and this is a very simple one, which I'm gonna start with this simple sprinkler, and after that you can even simulate this kind of complex sprinkler. The setup is very simple, but the most important thing is that you have to know about the structure. For example, it has 5 sources, maybe more. It has more than 5 sources. It has one source, and it is a curvy source. And also check the animation, how it moves, how it works, the main structure. That is very important. Okay, if you can see in this setup, I used a cylinder as a main structure. You can see it's a very simple cylinder and a chamfer modifier on top of this, and then I add a dummy object as a helper, and then I animate it. If I isolate the dummy, you will see that it has a very simple animation. Let me play it. I animated just in real life. Very simple setup, very simple animation. It has 40 frame animation. Let me show you the graph. You can see that in Z rotation axis, I have a very simple rotation until 40, and then it loops. It has animation until the infinite. I made a very simple animation until 40 frame, and then click on it out of range types, change it to the loop. You can see that this loop option is enabled, then OK. You can change it. Let me, for example, cycle, or linear. You can see everything gonna change, but I put it on loop option because I want to have a loop, infinite loop. If I increase the time, I have infinite loop animation. Okay, so put it back to 100 frame. That's enough for this video, and unhide all. Sorry, just hit the cancel, escape for the simulation of Tyflow, and refresh it again. Okay, it is a very simple helper, animated helper, and then let me isolate it again. I select these, and also I made a tie icon here with a very simple setting. It is almost default, but change the length and width to 1 centimeter and move it this side. Then select this, select this, select and link, select it and link to the dummy object. That's it. That is the main point and the most important things in this simulation. Then if I start playing the animation, you can see that everything links together. Tie icon and the main structure of the sprinkler link to the dummy object. And then let me unhide all. I made a Tyflow object here. Open editor. Let me show you step by step. Turn this off and let us start first with the birth operator. You can add this birth operator and let me just turn it off. And instead of total option, I use the per frame, maybe 250 in any frame. In each frame I'm gonna produce 250 particles per frame with the variation of 50% maybe. And then I add a position icon. Just you can see, just hit tab, position icon, and pick this icon, tie icon. You can see that we have some particles here. In every frame we have 250 particles with the variation of 50%. Then I'm gonna add a speed because we need a speed to the particles. It is just on random 3D, but I don't like this. I need a speed along this icon arrow, so I can change the direction to along icon arrow and pick this tie icon. Now we have speed to the particles along the icon, but it's infinite, you can see. Then we need a slow. The speed I think is too much. Maybe we can add a slow operator or not. Let me ignore it. We can add a spin operator because any kind of particles need to spin, and in random 3D axis, and the axis is on random 3D. That's okay. And then we need a gravity. I just add a force and change it to negative value, maybe negative 0.2 is too much. Let me change it to real world. Also I can change the speed maybe to 10 centimeters. 15. I think 15 is okay. And also we need some noises. I can add 1.5 noise. Maybe more. Scale 35, 20. So noisy. I think that's okay. And these particles need to turn into a shape. I can add a shape operator. And 3D, I can use octahedron and also Don't forget to change the display option to the geometry. You can see we have the shapes. Maybe scale it and scale it to 60. $50. I think it is okay. And if you can see here, these sprinklers, when they produce water after some frames, after some seconds, it will goes down and it has collision with the grass, with the ground. So in real life, it is not much visible also in rendering. So we can, if I have a plane in here, you can add a collision to have collision with this ground. But adding collision option, it will be heavy simulations, so I'm not gonna use this collision. Instead of this, I'm gonna use a condition operator, a time test operator. Let me change the output side here and add a delete operator. And tell Tyflow after maybe time test event age, just change to the particle age. That I'm gonna tell Tyflow that from producing these particles in every frame until maybe 20 frame with the age of particles with the variation of 3 frames, then go to this event and delete. You can see, but I think it's too much. I can change it to 50. Let me create a plane. I can reduce it 20, 10, the variation of 1, 2, 12, 13, 14, 15. I think this is okay. Yep. Let me delete it again. I think the noise is too much. I can go back and change the noise parameters to 1, scale it to 50. Okay, now it's okay. This is the simple setup, the very simple setup for any kind of sprinkler. But the most important thing is the Tyflow setting. If you can see here, the time step is now on 1/16. The default is frame. Just look at this simulation. This is the default setup, default setting of Tyflow. But if I change it to, for example, 1, 2, I can it is half of the frame. It means that from frame 0 to frame 1 we have 2 frame. Increase it. Now we have 4 parts from frame 0 to frame 1. We are increasing the details, but don't forget that this increasing the time step, it will increase your the calculation time. If I put 1/8, we have more particles. 112, 160, Also, I can change the birth to maybe 1200. The variation of 50, maybe 85. That's 50 is okay. Position icon, speed, magnitude of 50, but I'm gonna change the variation and need much more randomization here, maybe 35. You're seeing that we have much more better simulation. 35, I think it's too much. Maybe 10%. %. Yeah, I think this is okay. Maybe 10 is a great number for this. Yes. The Tyflow is very fast. You can see that the simulation is very fast. Let me show you. 100 frame, finish and play it. You can use this setup, and finally you can add a material on it. You can add a water material, and be sure to turn on the motion blur on your camera, and then everything is great for the final render. So this is the first one and the simplest one for the sprinkler simulation. Let me show you the next one. Here is the second one. The second setup is very simple. Let me show you the simple. It is exactly the previous one with birth, position icon, speed along icon arrow, slow, maybe you can turn it off, spin to have randomization on your particles, force to add some gravity plus noise. You can see that we have negative value and some noises. Shapes to turn the particle into the shapes. I used a 3D octahedron, and you can use a scale or not to use. It depends on you, it depends on your desire. And then add time test, a condition operator, put it to the particle age just like before, and delete the particles. Also, you can use the property test and tell Tyflow that blue. Let me show you here. Add a property test. Okay, and change it to the position Z and less than maybe 10. Let me turn it off. Less than 10 centimeters. Delete this. Yep. Property test, position Z, negative value. Let me show you. Now we have deleting the particles less than negative 10 centimeters to prevent lots of particles, producing lots of particles. Very simple. Or you can use very simply time test with the age of particles. And also don't forget to change the time step to 1/16, maybe more, to add more particles. Let me change it to maybe 1001 and 500 to have more particles, to have more details. You can see Tyflow is very fast. Let me show you. Okay, this setup is very similar to the previous one, exactly the previous one, but the difference is the structure. You can see here we have another cylinder and chamfer on it. If I make it from scratch, let me show you. Just go to the helpers and create a dummy. Shift A to the cylinder and move it. And here I'm gonna show you. And then go to the Tyflow and add a tie icon. Tie icon. Change the size to 1 centimeter, 1 centimeter, maybe lower, and Shift A to this dummy object. Rotate it maybe 45, first 90 degree and then 45 here. Then change the pivot point, very simple way, to the align to this object. That's it. And you can rotate it. Let me affect pivot only, align to this object. Okay, and turn it off. Just hold shift and make some copy, maybe 1 2 3 4 5, sorry, maybe more. Seven, yep. And you can just add animation to this dummy object, maybe from frame 0 to frame, oh, it's calculating. Let me turn off the auto key and select this, isolate, and now turn on the auto key from frame 0 to frame 100. Just rotate it maybe this. You can see we have very simple rotation animation. And go to the graph editor, change it to the linear, and then go to the outer fringe and change to constant, maybe constant, maybe linear. I think this is okay. If I yes. So in graph editor you can choose this option, linear relative repeat, okay, and close it. Then select all, deselect this, select the link, this. Also you have to select the cylinder and link it. We have very simple animation. If I play, this is a very simple animation. So I delete this, we have this simple setup. You can see that we have animated tie icons. Then the Tyflow setup is the previous one, exactly the same. And don't forget to change the time step. This is for the second setup of the sprinkler. And here is the last one. The last one is also the same setup with the time step of 1/16. Exactly the same flow of Tyflow. Birth operator, position icon, until time test and delete. A different per frame particles 350, and but the difference is again and the structure. Here also I have this. Let me isolate it. If you can see here in this kind of sprinklers, it has a curvy structure, and I made it exactly the same, just like this. A curvy tie icon with very simple animation. I just add the dummy object and animate it, and then change it to the loop, because I need a loop that I have the infinite loop animation. Let me put it back to 100 frames. Okay, and then select these tie icons and copy into a curvy path, and then select all of this, deselect the dummy object, select and link to this dummy object. That's it. This is the main point. And then we have this. If I unhide all, let me increase the number of particles, maybe 2500 or 1500. Also be sure to check this on display particle counts, because you can see the number of particles here to control the particles. Okay, clay option, and here is the final result for the last setup of the sprinkler. Let Tyflow finish the calculation for 100 frames. It's very fast. For 1000, more than 1000 particles per frame, it's so fast. Okay, just play. We have very nice sprinkler. Then finally you can add a mesh operator here, then add a water material, then render it. Okay, that's it for today's video, and thanks for watching and take care.